G'day everybody, Nick Dingle here with the second part of our virtual reality tower defense game. So if you missed the first part of that one, check the description of the video. I'll give you a link to the first one. Now in this one, I want to create the first basic tower that we're going to be creating, getting it shooting at an enemy. The enemy's not going to be doing anything at all. And that's probably going to be enough just for this part of this video. So to begin with, I want to set up just the visual aspect of it. So we're going to create a cylinder. For this one, we are firstly going to call it Basic Tower. Now you saw in my previous video I had it called Regular Tower. I really didn't like that name, and I came up with a better one later on. So the first thing I want to do is set him to 0, 0, 0. So he's right smack bang in the middle. I want to set his scale to 0.5, 0.5, excuse me, 0.5. And the last thing I want to do just to this guy is remove his collider. Now the reason I want to get rid of the collider is because I don't want this guy involved in any collisions throughout the entire game, okay? He creates collisions. He's not going to be involved in any of them, okay? The next thing is let's get the turret on the end of it. So I'm going to right click on Basic Tower and create a cube. You can see he's way too big and embedded in him. So the second I create this, let's call him Barrel, not Narrel. Barrel is a better name. Get rid of his box collider because the same thing about the cylinder. We don't want him involved in any collisions at all. And let's set up his position and scale. So I'm just going to grab the scale tool and I'm going to do this by hand. Scale. Whoops, I'm scaling that too much. Up and down. Let's pull him up. And that's forward. So I'm going to have to rotate him around. Whoops. Around like that. And pull him forward. Alright, not too bad. He's probably a little bit too high. There we go. There's my basic tower at this point. Before we finish up, I'm actually going to put another object on top of him. I'm going to right click on barrel. We're going to create an empty object. I'm going to use this little icon. If you've never used this guy, he's really, really cool. But he gives you a tag within your world that you can look at. Okay? And I'm going to call it exit. Now the reason I'm creating this guy is because, what is his? He needs to be 0.5, so I can type that in, thankfully. The reason I create him is because that's where we want the bullets to spawn, okay? If we were to use the barrel to spawn the bullets, they would actually appear from this spot in the middle of the barrel. So creating an exit on the end means the bullets are going to pop out those and shoot out in a more natural, I suppose, way. So let's create a material for this guy too. So let's go materials, create material, and let's call him tower. This guy, I am very, very cheap, and we're just going to do a very darkish red. And I'm going to, once again, turn the smoothing off, no highlights, drag it on the tower, drag it onto the barrel. Okay, and that's pretty much it. That's the job done. Now, I might actually turn that little tag, that's going to annoy the heck out of me if I don't turn that off. Okay, because he's in the right spot now, I don't need to see him anymore. So, like with everything else that I've made so far, I am going to drag Mr. Basic Tower into my prefabs. And it's all good. Now you may have noticed as I've been working along on this stuff, these little pluses and all these little blue icons have started appearing. And if you haven't used it before, that is the collab features of Unity. It's fantastic. Okay, I'd suggest give it a go. It's free and it's really easy to use. All right. But these just indicate files that I have added to my project since I made my upload. So I am just going to keep working on this and you're going to see these appear all the time. And I want you just to try and ignore them if you don't use the collab features. Otherwise, I'd really, really recommend it. So, what we probably should do now is create this guy's bullet, okay? While I've got him out here and I can see like the scale of the bullet compared to him. I'm going to create a cube for the bullet. If you don't like it, you can use a sphere or any other shape you want. But for me, I'm just going to use a cube for something nice and simple. So this guy is going to be called bullet, funny enough. Let's set his position to 0s, just so I can see where he is. As for scale, let's just hold control, scale him down, and see how he goes. That probably looks like a good size. Let's grab that. Come on. What are you doing? It's probably a little bit smaller. There we go. So what's that? Wow, that's pretty small. Anyway, you can see the numbers there if you want to type them in. So it says 0.08. Okay, and what I'm going to do is I'm going to leave the box collider on because obviously this bullet is going to be involved in collisions. I'm not going to tag him, however, because he's going to be the one causing collisions. Okay, I also don't want him running into objects like they're solid, so I'm going to tick the is trigger box. So they go through things, but he does cause collisions. Now, if you ever have a moving object, you need to make sure you have a rigid body on it. Even if you don't want proper physics simulations in your game, what you do if you don't want the physics simulations is you tick the is kinematic. All right, and every single object that I create that's going to move, and that includes this bullet and enemies and all assortments, I am going to add a rigid body and tick the is kinematic because it's a lot better in terms of efficiency. Now let's create a material for this guy as well. So material, boulet, and the color I chose I think was a bright yellow. So this one was 230, 255, 0. It is definitely bright yellow, so it stands out. Again, no smoothness, no specular. Drag it on the bullet. There you go. You can see it stands out a lot. All right, and once more, we're going to prefab this guy as well. Okay, so let's move him out of the way so he's not inside. I'm going to save my scene. I do this pretty often. I just control S randomly every now and again. And the last thing I want to do, we're going to create the enemy that this guy is going to be shooting. So let's go right click, 3D object sphere, zeros, just to get him out of that wall there. All right, and the scales were 0.3 that I used. Now you can see that when I create this guy, he is stuck in the ground. So once again, okay, 0.5 to pull him up out of the ground, just like we did with that initial wall piece. Okay, this guy is going to be a trigger as well because he's going to collide with that end goal, the thing you're going to protect. And we're going to get some tags for him because he's going to be involved in lots of collisions with bullets. So add. Oh my god, I am not thinking clearly. Jesus Christ. Enemy. Wow, that was quality. I should probably name him to small enemy. Okay, tag him as enemy, not tag. Far out, that was stupid. The other thing I'm going to do is add a layer to him. Now, the reason I'm creating a layer for the enemy is my towers are going to be doing lots of collision checking. They're going to be checking who's around them and who's close enough to shoot. Okay, and by using a layer called enemy, we can actually filter out every single object in the entire game except for the enemies. So that means we can do collisions around the turrets and it ignores all the ground, all the walls, and any special piece, or all the other turrets I should say as well, and any other special little environmental things that you want to put in. It ignores all that and only focuses on the enemies. Okay, now because this guy is going to be moving, once again, add a rigid body and make it is kinematic. Alright, and then let's create a material for this guy as well. Almost made it in the wrong folder, which I've done quite often. Small enemy. The color for this guy, it was like a bluey sort of color. So 69186 255. Shouldn't have had to change that, but anyway. Smooth as down, no highlights. That's you. And I just use these colors because I think they stand out amongst each other quite effectively. Okay. And like everything else in the entire game, prefabs, small enemy, go in there. Okay. Now you're probably sick of creating prefabs and setting up the materials and all that kind of stuff by this point, and that's good because we're about to create our first script. So let's click on scripts and let's create our tower scripts. Now this guy's got a lot of functionality and it's actually fairly complicated, but I want to take it step by step and show you exactly what I'm doing and hopefully explain everything in such a way that you understand what I'm doing as well. I'm going to create a new script, and every script I do is going to be C#. I don't do JavaScript, I'm sorry. And I'm going to call it tower. I use fairly simple names for my scripts just to keep them, well, self-explanatory, I suppose. And the first thing I'm going to focus on is getting a tower, picking a target. Now, here's the thing. Your target can easily get a list of all the enemies in the world and just target the first one it sees, okay? That requires a little bit of work. What I'm going to do is we're going to use a special function to check how many enemies are in our range. Then we're going to find the enemy that is the closest to us, and we're going to focus on that one. Okay, so there's a little bit of work that we have to do here, and unfortunately that's the first function we have to use. So right at the very top here, I want to create a variable. Now this variable is going to be a number, and it's going to tell us how far the turret can shoot. It's going to be pretty simple. I'm going to go public float range, and I think 3 was that initial number that I used. So the next thing that we have to look at is finding that target within that range of 3. So what I'm going to do every time I create something or I have an idea for a function, I actually create a whole new function. So I'm going to delete all the stuff that was there. We might bring some of it back later, but delete it for the moment. And I'm going to create one called void find next target. Okay. Just like so, you see our round brackets at the end and a curly bracket to denote the start of this function and a curly bracket to denote the end of that function. Okay. And the way this works is firstly, we're going to do what's called a overlap sphere. Okay. And the way this works is pretty simplistic. Okay. I want you to imagine that every single frame, we are going to create a sphere right from the center of this tower. And the range of the sphere is also the range of our turret is going to be the size of the sphere. So if the turret is, oh yeah, that's why it was so weird. Sorry, thinking about multiple things. So if the turret has a range of 3, that means the scale of the sphere is going to be 3. So that here is effectively the range of our turret. Now let me just, can I change the color of that? No, I can't. Doesn't really matter. So as soon as the enemy gets within that sphere there, we can pick up that he's touched the sphere, and then we have to check which one's the closest because there might be multiple within that sphere. And then once we've found it, we'll pick our target and then we start shooting at him. Okay, so I'll delete that sphere because we don't need that. That was just a representation of how it's going to work. The first thing is we see who's in our range. Now, if you haven't done much programming, this here is a comment. It's a line of code that is completely ignored by Unity, and we can just write whatever we want after the 2 forward slashes. So the way we do an overlap sphere is pretty easy. You go physics.overlap sphere. You can see there's lots of different options I had here, but sphere was obviously the easiest. And it asks you, where do you want to create the sphere? I want to create it where the tower is. So that is transform.position. The transform position tells you the position of the object that owns this script, which will be the tower. Okay. The second is the radius, which is our range. And that's how easy it is to do an overlap sphere. Now, to actually get information out of this function, we need to capture the results. And the result is right here, collider with square brackets, multiple colliders. So I go collider, multiple colliders, and I'm going to call it enemies. Okay, so I perform my overlap sphere at the position of the tower at that 3 range, and then that result goes into enemies, and then I can start doing whatever I want with it. So if I get 0 enemies, obviously we need to check that. But if I get 5 enemies, I can go through and check which enemy of the 5 is the closest. All right. So on that note, I am going to check if we hit something. So check if not hit something, we are in range. That's a better way of saying it. So we go if enemies.length is greater than 0, then we can do stuff. Simple as this. Actually, yeah, no, I'll leave it like that. Okay, so now it's time to find the closest one, and you'll probably hate me for this because this is going to be a fairly complicated piece of code. All right. In fact, to perform what I'm about to do, I need to add another variable at the top. And this guy, I'm going to put a line down. It's what's called a transform, and his name is target. This is going to be the guy we are targeting, obviously. All right. A transform, as you've probably seen it appear on every single object, is a position, rotation, scale of an object. And that's all we need to know about a target is where it is in the world. We don't need to know its name. We don't need to know it's got a collider. We don't need to know it's blue. We only need to know where it is. Okay. So the way, what we're going to do is we're going to assume the first enemy is the closest. Okay. And the reason I always assume the first enemy is the closest is that you've got then a benchmark to compare the rest of the enemies to. So what you do there is you go target equals enemies, 0, and then I need to get the transform of the enemy. And to get that, you need to do .gameObject.transform. Okay, fairly simplistic in a way. Now what I need to do to compare this guy compared to the rest of them, I need to loop through the rest of my enemies and check their distance as well. So let's loop through all the enemies. For each brackets, and I go collider enemy in enemies. Okay, so this just is basically saying for every enemy inside that list of enemies, perform this code. So we need to calculate the distance between the tower and that next enemy. So calculate the distance of the enemy to the tower. And the way we do that, I'm going to create a float called distance. Okay, and it equals vector3.distance. Lovely little function Unity set up for us. Okay, how far away from the tower's position and the enemy's, whoop, shouldn't put enemies, I put enemy transform position. So this is going to calculate the distance between the tower and the next enemy in my list and give me that distance basically in units. So if it is 1.5 units away, the distance will be 1.5. Simple as that. Now what do you do? I'm going to compare this distance to our current target. Okay, and if we have a smaller distance, that means we have a new target to point at because he's actually closer than the previous target. Okay, see who is closer. So if distance is smaller, and I need to do another distance calculation here. Sorry about a complicated looking code here. Transform.position target.position. Okay, so I'm comparing the distance that we just calculated to the distance we had with our previous target, and that's asking, is the new distance smaller? If the answer is yes, then you update which target we have. It's the exact same code we just did up there, but slightly different. Okay, and that's it. All right, this code here in this loop is going to tell us who is the closest target, and by the time we get out of the loop, we should have the target, which is the very closest of all of them. Now, there is one last thing we have to do here. If we have 0 enemies in our list, we have to make sure that we don't have a target. Okay? Because obviously the target may have gotten out of our range, or there's something else that's gone on here, or there just has been no targets since the beginning of the game. So what I'm going to do is make sure you've got the right bracket that this matches up to. And if you've got the newest version of Visual Studio, you can mouse over and see if length is greater than 0. So you see it, this bracket matches up to this one. You can follow the dotted line, and you can also click on the edge of a bracket and see it highlights the other one. I apologize if you're experienced in programming and I'm telling you to suck eggs. But anyway, if we have 0 enemies, I want to put an else down here. And this is basically saying, if we have enemies, go find the closest one. Otherwise, our target is null. Now, target equals null means we have nothing. Null is nothing. It's empty. It's gone. It's a void of nothingness. So that means we have absolutely no target to go towards. Okay. Now this is a complicated piece of code that I just spent ages explaining and setting up and da-da-da-da-da. How do we actually use it? Well, I'm going to use it in void update. I shouldn't have deleted it before, but up the top here, put void update. It's going to get rid of that word private. I don't like the way it puts that in. And the only line of code in here is going to be find next target with brackets and a semicolon. Okay, so every single frame, I'm going to try and find the next target. Okay, so we're continually updating to see who is the closest target. And that's why when you saw my little demonstration, the towers are flicking around at different targets as they got closer and further away. Right? It's as simple as that. Now we can test this code. So I'm going to go back to Unity and I'm going to drop the script onto my basic tower. Okay, whoop, flop, I didn't get any errors. Nope, no runtime errors or whatever, not runtime errors, syntax errors is the word I'm looking for. And what I'm going to do, every time I make a big change to a prefab, make sure you come up here on the tower and you hit apply and all those settings go away from being bold. Okay, that makes sure that all your prefabs are going to have those settings as well. So the way that we're going to test this, okay, and it's a little bit different because if I hit play, we have got a target and it is close enough. Whoop, I need to look down. So this little enemy here is close enough for this target, this tower. It is really difficult for me to test this code to see if that is the closest sphere. So what I'm going to do is I'm going to open up. You can see range is here and it's got the number 3. And the reason I can see range is because it's public. So all I need to do to test this is put public in front of the transform. Wait for it to pop up here. It should say empty or none. Sorry. And when I press play, hopefully that says small enemy, if I've done this correctly. Oh, I'm going to go back to minimize screen. Okay, nope. Apparently our closest target is the ground. And I know why, because I actually skipped over a line of code, and it's something very important that I described to you in a lot of detail at the beginning of the video. So I was talking about the idea that I wanted the enemies to be on a layer so I could ignore every single object and only attack the enemies. I haven't actually done that. And it's to do with this overlap sphere. Now, it's a good thing I tested this code and not moved on. Otherwise, I would never have done this. So the way we do this is there's a third option that you can do in an overlap sphere, and it's called a layer mask. Now, the layer mask is this guy right here, the layer. Now, unfortunately, you can't type in the name enemy. It wants a number. Okay, and here's the other thing. If I go to add layer, you see that is user layer number 8. So it's not as simple actually as me typing the number 8. It doesn't work like that. Okay, if you know a little bit of binary, this is actually a bit shifted integer. Now, I'm not going to go into how it works, but basically the way we're going to set it up is I'm going to have a little integer here called layer mask, like so, and I'm going to make it equal 1 bit shift left 8. Right, and then instead of writing the number 8 here, you put layer mask, like so. All right. To explain how that works quickly, okay, it's layer number 8. So if you have a layer number 9 or layer number 10, you only need to change that one number just there, okay, and that is it. But what this is going to do now is it's going to filter out every single layer in the entire game except for the enemy layer. So it's only going to be looking for enemies at this point. So if I press play, hopefully if I click on that tower, you see he's looking at the small enemy, and if the small enemy happens to run away too far, it should say none. And when he gets close enough, obviously, come back here, he's going to be targeting the small enemy again. Okay? That is how we can test the scripts and fix our problems. Let me just go away, environment. All right. So things are actually looking pretty good at this point. So what I'm going to do is get rid of the public, because I actually don't want that there, because that can cause problems if you leave that as public, just in case. And the next thing we're going to do is we're going to start aiming at the enemy that we are targeting. Okay, this is a little bit, you're probably thinking right now, why didn't I implement this, okay, before I did the public target, It's actually a lot better if I test this bit of code first and then build on top of it after. As you can see, you'll probably run into problems otherwise. So next function is going to be called aim at target. Okay, it's going to probably sound very simple. Well, you just point that turret down towards the ball. And if he's close enough, or if he's somewhere else, you just rotate it around. Yeah, it's actually not that simple. If you've ever done rotation maths, if you've ever let me start that again. If you've ever seen quaternions, then you'll know exactly why this is not simple. So what we need to do, this is a piece of code that I found a long, long time ago, and I've adapted again and again and again throughout a lot of projects. So I honestly can't remember where I found it. And this is going to look at our target. The first thing we're going to do is calculate the direction we need to look. Okay? And I call it my look position. So target.position minus transform.position. So we're taking the position of the enemy and the position of the tower, and we subtract them. And what that does is actually creates an arrow pointing from our tower down to the enemy. Now, I only want the tower to rotate around the y-axis like this. So the way to do this is you go look pos.y equals 0, and that locks in to only rotate around the y position. I know that sounds silly, but that's how it works. The next step is to calculate the rotation of the object. So you do quaternion rotation equals quaternion.look rotation, and in brackets look pos. Okay, so that basically creates a rotation based on that arrow that we generated. And then the rotation transform.rotation of the tower equals that new rotation we just calculated. Right. To use this code, we're going to go back up into void update, and we're going to plug it in. Before we do, we need to make sure we have a target. So let's ask the question. If target does not equal null, okay, so in other words, we have something, aim at target. Simple as that. If I jump back here, hopefully that code works, and I should be able to move the enemy around. You see the turret, follow it intently. But you can see it doesn't go up and down, it just goes around, which is actually the result that I wanted, personally. Alright, so again, code is working. Next step, let's implement the shooting at the enemy, because that's probably the most interesting thing that you're going to do. So we're going to have another function called shoot, but before we set that up, we have a couple of variables that we need for that one, and that's basically going to be the fire rate. So up here underneath the range, I'm going to put public float fire rate, capital R, equals 1, which I think is what I ended up with. You can probably use a smaller number means quicker, a larger number means slower. We then need to know what the bullet that we're going to create is, because I want to keep this script fairly generic for as many different types of towers as you'd like. I am going to create a public game object called bullet prefab, so we can load in what type of bullet that this tower is going to generate. Right, so if you want just regular little bullets like the one I created before, or you want big ass bombs, or you want quick little snappy ones, I don't really want to know. Anyway, the next bit is we're going to create the position where we create the bullets, which was that exit that we put at the end of it. So public transform, and I'm going to call it barrel exit, like so. So the reason I know this is I use a game object for the bullet prefab is I'm going to create a whole object. And the only reason I use a transform for the exit is because I only need to know a single little position. Now, for this fire rate to work, I actually have to have one more variable, okay? And I call this the counter. And the way it works is sort of like a stopwatch, okay? I press the button in, okay, and it counts down from my fire rate. So it starts at 1 and it slowly goes down. As soon as it hits 0, that means we shoot another bullet, and it goes back up to 1 and it starts going back down again. Now, obviously when we code it, I'll explain how that works, but I'm going to create a float fire counter and make it start at 0, which means we can shoot straight away if we want to. All right, and it's time to actually set up our shoot function. So if you've got all those variables set up and it hasn't confused you too much, come down to the bottom of the script and let's create a shoot function. So let's go void shoot squigglies. And the first question we should be asking is if the fire counter is at 0 or less than 0, just in case we stuff some up. Okay, then we're allowed to shoot. So see if we can shoot yet. Capitals. If fire counter is less than or equal to 0, then we're going to create the bullet. So you create objects, like any object that you want to create is called instantiate. Right? And instantiate, you need at least 3 things. You need the object you're creating, you need the position you want to create it at, and the rotation it's going to have. All right, so for this one, we're going to use the bullet prefab. The position is going to be the barrel exit dot position. And then finally, the rotation, I don't actually want it to start with any particular rotation at all. Sometimes you do, but this one I don't. And it's going to be called quaternion.identity. All right, that might be really, really weird, but identity just means default turn. Okay. Now, without changing too much code, I'm going to hook this up into the update, and we're going to see it spit out a ton of bullets. So up here, shoot. Oh, like so. Let's press play and watch it go crazy. Watch my little list. Hopefully it works. Oh no, I stuffed something up, and it's something I'm going to stuff up a lot, I reckon. I didn't hook up my bullet prefab or my barrel exit. So what I'm going to do to put in the bullet prefab, whenever I use a prefab object, I'm actually going to go to the prefabs folder and drop that in from there, not from the game. Okay, because that one's specific to the level. This one down here is specific to the whole game. Okay, and for the barrel exit, obviously I want the exit object here. Now I've made changes to a prefab, so I'm going to apply them to make sure they stick. Hopefully we get tons and tons of bullet clones. I'm going to stop that before it crashes my game. And you can see it was spitting it out at the end of the tower. So it's obviously trying to shoot my guy or my little enemy. So to fix this up, we obviously need to have it so it only shoots at a certain amount of time. So what I'm going to do is use this counter finally as that stopwatch. It's set at 0 and I'm not increasing it anything above 0. So the way we do that is I'm going to go fire counter equals fire rate. Okay, that's all well and good. That's going to go from 0 all the way up to 1 because of the fire rate. But the problem is then, how do I bring it back down? Well, the way you bring it back down is right down here. I'm going to put an else. Okay, that means that we haven't shot anything. So in the else, I'm going to go fire counter minus equals times time dot delta time. So what I'm doing here is I'm subtracting how much time has passed since I looked at this code. And generally speaking, it's like 0.5 of a, oh, no, it's even less than that. It's like 0.5 of a millisecond or whatever like that. 50 milliseconds, I should say. All right, so that's going to take away a fraction of fire counter, and it's going to have to do this lots and lots and lots to get to 0 or anything just a bit below 0. All right, and then it brings it back up to 1, and then we have to wait for it to decrease again before we can shoot again. But this is the fire rates done and dusted. So let's hopefully see it pop out every second. So that's actually our tower 100% done. He finds targets, he aims at them, and he shoots. That's all of his jobs done. Okay? And like with any towers, if you want to create another tower, a more advanced one, all you have to do really is then modify the range, the fire rate, and the bullets that it shoots. That's all you have to do there. And you can even obviously change the way it looks and everything. But for the moment, we need to get the bullets working. Okay, the bullets are very, very important, and they just sit there. So what I'm going to do is we are going to set up another script before the end of this video. Pretty sure. Yep. Okay, right click, create, C#, call it bullet, open it up. If you ever get this question, just go, yeah, reload solution, whatever you reckon. Okay, now this guy is going to be fairly simplistic. All he does is he has a target, which is going to be that enemy, and he just runs at him. That is it, and hopefully he hits him. And the way I've set up this code is he will always have to hit him, regardless. There is one exception there, but generally speaking, that's how he's going to work. So we first of all need a public transform and a target, just like we had on the tower. Now the reason he's public is because the tower tells the bullet what his target is. Okay. Second thing is, if I ever do any movement stuff, I like to have a speed setting. So I'm going to have public float speed equals, and I think I had 10 as default. We can always change that. So if you've got movement code, make sure you've got a speed variable in there so you can modify it in the editor. So before we go anywhere, I'm going to use start and update this time around. I don't like these comments, so I get rid of them. Space out my code a little. And I don't use void start for this. I use void awake all the time. Okay. So what we're going to do, awake is essentially like start. It executes some code at the very beginning of the script. Okay. Awake's just a very good time to start doing this kind of interactive code. When the bullet spawns, I want him to look at his target straight away. Okay, and that's it. Simple little thing you can do. So transform dot look at target. All right, and the reason I do that is just gives a nice little effect off the bullet is facing that direction. So especially if you're using a cylinder, the cylinder can face the right direction. Okay, and then in update, we're just going to move towards that position. And there's heaps and heaps of ways you can do movements. You could do transform.translate, you can do the rigid bodies.move position, you can do rigid body velocities, or you can do character controller.move. The one that I like the most at the moment is vector3.move towards, because I can control the speed quite easily. I can control where it is and the actual position I want to get to. And when it arrives at the position, it doesn't go all crazy and flick around, it just sits there. Okay? Obviously we don't want our bullets to do that, but while we're testing, it's really easy. So one line of code in both update and awake is going to get this working. So this is move to the target's position. And the way you use vector3 move forwards is you need to modify the bullet's position. So transform.position equals vector3 dot move towards. In brackets we do the bullet's position, and what's our target? It's our target's position. I cannot type at the moment. And then what is our max distance delta? Okay, so how far are we going? Well, it's going to be our speed, and it's always good when you use speed to do time dot delta time. Okay, to make sure that no matter what device this is running on, the bullet will move at a consistent pace. All right. This is actually pretty much done. To give it a quick test, what I'm going to do is click on this bullet. I'm going to add the script to him. So bullet. And as I said, with anything like this, I am going to hit apply to make sure that it applies to the prefab as well. And to test out the target, I'm simply going to put small enemy in the firing line. I'm going to move the bullet up and back a little bit. Hopefully the bullet shoots straight at the enemy. And you see he sits in the middle of the sphere. And it just makes things a lot easier when you use the move towards. Okay, so that's actually working. Perfect. But you can see I've got some nice little errors here. And that's because when I'm generating, it's whinging about this. It's saying I don't have a target. And that's because when I create a bullet during the game, here, I'm not giving the bullet a target towards. Okay, so the way that we're going to do that now is we are going to add a couple little modifications to this code. Where am I? Oh, there we are. Sorry, looking at the other screen. I'm going to create a variable called GameObject. It's going to be called newBullet. And I'm going to make it equal instantiate. This is a way that you capture the newest bullet that you just created. And then what I'm going to do is allocate that new bullet a target. So new bullet, I have to access that script, which is called bullet. And the way you do that is .get component bullet, brackets on the end, .target equals, now this is really, really simple. His target, the bullet's target is the tower's target. So that's the target of the bullet. This is the target of the tower. Okay? So we're saying what I'm shooting, you're shooting. So hopefully now, if I quickly jump here, you'll see the bullets flying at the enemy. Give it a shot. No pun in. And you see the bullets aren't getting destroyed or anything. They're simply going into the enemy. And as we move him around too, yeah, and if he goes too far, he should stop shooting. No more bullets. Simple as that. All right. So shooting is all well and good, but you can see the bullets were retaining inside the enemy there. They weren't hitting him. They weren't destroying. They weren't impacting any damage or anything like that. So the last thing we're going to do in this video is actually check the collisions between the enemy and the bullet. So this is going to be done on the bullet script, and it's really, really simple to do. So right down here, I'm actually going to destroy this code here, by the way, guys. I could see it wasn't really doing much. I didn't like it. Bye-bye. Doesn't really matter. We're going to use what's called an on-trigger enter. Now, remember we ticked the little box of the bullet that said he is a trigger. That's why I can use this on-trigger enter. So I'm going to, if you're using the newest version of Visual Studio, you can just double-click on this suggestion, and it plops it all in there. And again, you can drop the private. You don't need that word there. If you're using an older version and you didn't get that option, you simply have to type it all in. Lovely days. Now this is really good because when our bullet collides with something else, that something else is going to be put inside this variable. So if it's the enemy, that other is going to be the enemy. If it hits a wall, unfortunately, that's going to be in there as well. So we have to do a check to see if we actually hit an enemy or something else. Okay. So what I'm going to do first of all, I want to extract the object that we hit because it's a collider and I need to know what the actual object was. So I create something called OBJ, short for object, equals other.gameObject. That's how I extract it out. And I check if it's good spelling. The enemy, we go if obj.tag equals quotes enemy. Okay, so that's why it's handy to create tags for things that you know are going to be done with collisions because we're checking it already. Now, if we hit an enemy, I'm going to send a message to that enemy that we did damage to him. Okay, and I'm going to create a function in the future called hurt. Now, if we're going to hurt something, we need to know how much damage that this bullet's going to deal. So quickly before we do anything, up the top, public float damage equals, what did I have it as? 5? I think in the previous project. Yeah, that sounds about right. Now the way we send messages to other objects is you go obj.sendMessage. Okay, it wants to know what message you're sending. Well, I'm sending a message that I hurt you. And I put a quote and it says, what's the value of that? Well, it's damage. Okay, so I hurt him for 5 damage. Okay, and the next thing you really want to do is destroy the bullet straight away. So destroy game object, just like so. So this doesn't destroy the enemy. Okay, this destroys, yeah, because you can see the description, the game object this component is attached to, which is the bullet. So it destroys the bullet. Now there's only one more if statement I want to put in here, and that's if we hit the ground. So I'm going to put an else if object tag equals ground. Now if I hit the bullet hit the ground, I'm just going to destroy the bullet. Okay, there's only very few instances where this can happen, and I'm just catering for it by putting this bit of code in there. Okay, so if we have a quick look, not much is going to happen. You just see the bullets go in and they'll disappear, and I'll get a lovely little error message down the bottom. You'll see the errors are counting up. But you can see that the bullets aren't stacking up anymore. They're just shooting in and they're disappearing. Okay. The reason I'm getting these errors, it's basically saying that the enemy that I'm hitting doesn't have anything ready to accept the hurt message. Okay, you need to fix that stuff up now. We are going to fix that later on. Okay, right now, this is pretty darn good, I personally think. We know this is working. Now, I did have one other instance when I had multiple errors, that is. I should probably finish my sentence before I continue. But essentially, I had a problem where if the enemy was killed while the bullet was traveling towards him, so there was 2 towers shooting one enemy, one turret killed the enemy before the second one could actually hit him, I was getting errors with this guy, with Unity whinging that the target was already destroyed. So what I actually need to do is put an if statement around this stuff. I need to check if the target exists, basically. So, same thing we did in the previous one. If the target does not equal null, then we do this move code. So I'm going to cut this, paste it there. Okay. Now, if the target has been destroyed by another turret, then there's no point in this bullet existing. So I'm going to put an else, and I'm going to do destroy game object. So you've seen that 3 times now already. So again, if we have no target, there's no point in the bullet being anywhere or doing anything. So we just get rid of the bullet so it doesn't float around or sit in the middle of nowhere. All right. And on that note, we are actually done. I know that took a hell of a long time, and I know that was a pretty intense video, but thank you very much for watching, guys. I really do actually appreciate it, and I hope you learned something. In the next video, we're going to delve a little bit further into creating our enemies and getting them actually walking around the world towards their target. Anyway, thank you very much for watching, guys. I'll see you in the next video. Ta-ta for now.